Okay, the first problem, you get a situation where the net force is said to have done 400 joules of work, while gravity does negative 200 joules of work. The question is, how much work is done by the other forces? Okay, well, net force is the sum of all the forces. Gravitational force is one of the forces. There have to be others because gravitational work does negative 200 joules of work, and net force does 400 joules of work. If gravitational force was the only force present, then it would be doing the same amount of work. It would be the net force, and then the work done by gravity would be the same as the work done by the net force. So how much work is done by other forces? Well, since the net force is the sum of all forces, delta W net, the work done by the net force, is the sum of the work done by all the forces. Okay? Sum of the work contributions of all the other forces. So, the sum of the work contributions of all the other forces includes the negative 200 joules done by gravity. There's the contribution of gravity, and then the work done by all other forces other than gravity, and that has to add up to your 400 joules, meaning the work done by the other forces is going to have to be 600 joules. You just add 200 joules to both sides, solve for the work done by the other forces, or just use common sense. If you're going to need to get 400 joules and something's doing negative 200, what do you need from everything else? Well, you need 600, because negative 200 and 600 gives you 400. Now here's another situation. The net force does negative 500 joules of work, and the change in potential energy is 300 joules. And that's a change in gravitational potential energy is 300 joules. So, what's the change in the kinetic energy of the object? And how much work is done by non-gravitational forces? Okay, well, the net work done on the system is negative 500 joules. Work done on the system by gravity is what? Well, the potential energy change is 300 joules, and we've defined potential energy change as being equal and opposite to the work done by conservative force. Gravity is a conservative force, so it follows if the change of gravitational potential energy is 300 joules, then the work done by the gravitational force on the system, I should put that word on there, is negative 300 joules. Okay, so that work done on the system, work done by gravity on the system is negative 300 joules, and then everything else, all other forces are non-gravitational, since this is all the work done by gravitational forces, so we call this work done by non-gravitational forces on the system. Okay? So now we have a simple equation, and we can conclude that non-gravitational forces have to do negative 200 joules of work on the system. Now let's just be clear about this idea that change in potential energy is equal and opposite to the work done by the gravitational force. Okay. Ball. If I lift the ball, does the gravitational force do positive work or negative work on the ball? Well, the gravitational force is down, the ball is moving upward, the displacement is in the direction opposite the force, so the work is negative. So as I raise the ball, gravity does negative work on the ball. Okay, but what happens to the potential energy of the ball? Well, we've defined potential energy as being equal and opposite to the work done by the conservative force, and gravity is a conservative force. So we know that it's going to be equal and opposite to the negative work done by gravity on the ball, so it's going to have to be positive. But more intuitively, because that's not real intuitive, it's not that hard to reason out if you think about it, but it's not all that intuitive. If I drop this ball onto my bare foot, okay, Well, I didn't really let it fall onto my bare foot. Besides, I've got steel-toed boots on. Okay, but if I drop this ball from here onto my bare foot, it's going to hurt. Okay, it's probably going to leave a bruise. If I raise the ball higher and drop it onto my foot, it's going to hit harder, hurt worse. So this has the potential to develop the energy to hit my foot pretty good. And this has even more potential to develop, has the potential to develop even more energy and hit my foot even harder. So potential energy is greater here than it is here. To summarize, when I raise this, gravity acts down, I'm moving up, so gravity's doing negative work. When I raise it, what we think of as the potential energy gets greater. So the change in potential energy has to be opposite to the work done by gravity.